And Databricks is also supporting us today in this meetup by sending a keynote speaker, Matei Zaharia. And he is, if you don't know him, he's an assistant professor of computer science at Stanford. He's chief technologist at Databricks. And he's one of the inventors of Apache Spark. And he's here today to talk about MLFlow. So, Matei, welcome.
All right. Thanks so much, Rodrigo. Let me just put on my slides. Okay, great. So yeah, thanks to Zalando for hosting me today and getting a big crowd of people at the meetup. And yeah, thanks everyone for coming by. Excited to give a talk here. This is the data engineering meetup, and one thing I wanted to point out is just last week we organized the Spark and AI Summit Europe, which was in Amsterdam this year, and we actually had a bunch of announcements about both Apache Spark and Delta Lake, our transactional storage layer over S3 that we had there. So you can watch all the keynotes for that online already, and also all the videos from the sessions will be available for free online if you want to learn more about that. But today I'm going to talk about basically a third open source project we're doing, MLFlow, which is focused on production machine learning and basically the platform around machine learning. So, and this is what I've been working on for the past year to year and a half. That's the main thing that I've been working on at Databricks. Just to give a bit of background, basically the issue here is that machine learning development is harder than traditional software development in a bunch of ways. Actually, data engineering has some of the same characteristics, but other ones here are specific to ML. And so we've been seeing this issue come up with a lot of users of Spark and of, in general, a lot of the users we talk with. So let me just point out some of the ways that it's different. So first of all, there's the goal of what you're trying to do. In traditional software, the goal is usually to meet some functional specification. For example, if I press this button, it deletes a file, or if this user has this permission in the database, they can read this data, or something like that. And it's relatively straightforward to check whether it meets it. Of course, it's a bunch of work, but it's kind of a Boolean thing. Either it meets the spec or it doesn't. In contrast, in machine learning, the goal is to optimize some kind of metric. For example, the click-through rate of people on something, or the accuracy of a model, or something like that. And usually there's always a way to make it better. And also there's a way that it can get worse if your job stops working well. And every small change in that can have a significant impact on the business. So as a result, you're constantly experimenting to improve this metric. You're also constantly monitoring it to see how it's doing. So that's one difference. This is a continuous thing you're trying to optimize. The second thing is what goes in. So in traditional software, the quality mostly depends on the code, and that's what decides whether you meet the spec or not. In contrast, in machine learning, by definition, machine learning is algorithms that generalize from data. So the quality depends on your input data. And it can also depend on the training method and tuning parameters, which you might have to change as the data changes. So there are more moving parts you have to look at, and maybe you have time to review all the code, but you can't manually review a petabyte of data that will be used to train something. So that's a challenge. And then finally, there's how you choose software. So traditional software, you pick one software stack, one database, one web application server, one JavaScript framework, whatever you do. In contrast, in machine learning, because you are trying to optimize and keep improving this metric in a potentially adversarial world, you want to be able to quickly compare many different software libraries and models and algorithms for the same task. So don't have someone saying, okay, we'll just use, TensorFlow for everything. You actually want to always pick and try and adapt the latest models and the latest things that come out to do that task better. And so that's for developing machine learning. And then once you productionize it, you have to keep all this stuff happening, as automatically as possible. So you have to keep feeding the application with new data and retraining, and all that stuff I mentioned was hard before somehow has to be automated. And also another challenge is that the different parts of this life cycle tend to be handled by different people with different backgrounds. So the data engineers are really good at preparing the data, making sure it lands on time, making sure it's consistent, fixing issues in that. But then usually someone else is good at tuning and designing the model, and maybe a third person understands the application. And if you're not careful transferring the application between these, it might, you might do the wrong thing. So just as some examples of the issues that come up, this one here is an ad tech firm. So this is a company that's primarily, is make or break for them how well they can bid on ads. And this is the chief scientist. So they say, I build hundreds of models per day to increase revenue using any machine learning library, MLlib, PyTorch, R, whatever it is. If there's a new promising model, we want to try it. And unfortunately, there's no easy way to see what data went into a model from a few weeks ago and rebuild it. So that's a big pain point. And so this is a smaller company, small team that fits in a room. This is a larger consumer electronics firm, and they say our company has hundreds of teams using machine learning worldwide, but we can't share work across them because when someone tries to use someone else's model and just run the code, it often doesn't even give the same result. So these challenges are pretty significant, and if you want to use machine learning, in many applications, you really have to tackle them. So one of the trends that's come up to tackle this is the idea of ML platforms. So basically, software frameworks to explicitly manage the machine learning lifecycle and get applications to production, kind of like CI/CD, software development tools for traditional software. So some of the best known ones are maybe the ones at the large tech companies that they wrote articles about, so things like FB Learner and Uber Michelangelo. But basically every company we talk with that is using machine learning is also developing some kind of ML platform. So it's something that everyone realizes they need. So the good thing about these is that they standardize the ML lifecycle. If you haven't seen these give you an API where you can define a pipeline or a job. You can say, okay, here's how we'll do data prep, here's how we'll do training, here's how we'll do deployment, maybe testing. And if you write against this API, they handle all the moving pieces, connecting them, and also some checks of how this is working over time. So it's great. People are very productive using them. But there are also some challenges. So often, because each company builds this internally, it's limited to a few algorithms or frameworks that they support. So that gets into the problem I talked about, where the ML and experts or developers would like to experiment with everything under the sun, and then this platform team can become a bottleneck that slows them down because they don't know how to manage that piece of software. And also, each one tends to be tied to each company's infrastructure, so there's no sharing across companies. So we saw, okay, this is a useful abstraction. It's doing really well inside these companies. And so we asked, can we provide these similar benefits, but in an open manner, so everyone can collaborate to build at least pieces of this, if not everything. And so that's what we're doing in MLFlow. It's a open source project, Apache license, to have an open source machine learning platform. And what we're trying to do is not just open source, but we also have this concept of open interface, which is we want to make sure that MLFlow works with any machine learning library, algorithm, language, any commercial service, even a closed source service that you think is good for machine learning. You should be able to plug it into MLFlow and coordinate it with all the other ones. And the way that we're doing that is by organizing it around very simple data models and REST APIs that you can connect to from anywhere. And just concepts like Docker, for example, for packaging things up so that you can easily have it run with either custom stuff or just third-party stuff that other people are building. So that's MLFlow. We launched this last year in June, and we had 3 components in the beginning: experiment tracking, reproducible workflows with projects, and something called model packaging that I'll talk about to easily ship the same model to different inference environments. And when we started this, we weren't sure what would be the demand for this. Would anyone actually want to work on it? And can you actually have one that's useful to a broad range of people? But since then, the community has grown quite fast. So we already have over 140 contributors to the code. For comparison, my team that works on it, my engineering team that works on it is about 10 engineers. So lots of non-Databricks contributors making significant contributions. We also have around 800,000 downloads per month on PyPy, which is a significant fraction compared to just machine learning libraries in general. And we have some companies such as Microsoft and RStudio that have made significant contributions. So we're excited to keep growing this project, and actually we want to add a lot more than these components, and that's one of the things we announced is actually a 4th component that I'll talk about a little bit later. Okay, so that's that's kind of the motivation for MLFlow. So next I want to show you a little bit of what it does, starting with these pieces to give you a sense of how it helps. And then I want to talk a little bit about roadmap and just answer questions about it as well. So I'm just going to walk through these components in turn and hopefully give you a sense of how this can help. So the first component is experiment tracking. We found this to be one of the most basic things people want, just to be productive, get the same results later, but also sometimes for governance reasons, like making sure that you didn't use data you weren't supposed to use or something like that. So let's look at experiment tracking. Without MLFlow, you can write some machine learning code. There are lots of libraries that are awesome, lots of new models coming out every day. But then usually what people use is basically like log statements and files to save stuff. So you might log various metrics, you might save your model as a file, and then it becomes really hard to track where these artifacts and metrics came from and what were you changing. So you end up with a console that looks like this. And then if you look at it, you ask, okay, I logged 2 parameters here, but what if I tune some other parameter? What was it in the previous ones? I don't know, because I wasn't logging it. What if I upgrade my machine learning library? Maybe there was a bug, and actually with the same code and the same parameters and the same input data, it will do better because I got a bug fix. What version of code was each of these results from, and so on. So it quickly becomes a pain to make these things work. Now, what does MLFlow do? So the thing we were inspired by here is just kind of structured logging. You can have in many applications, people create structured logging. And so what it does is it adds this simple API to log information as you go along. And then it organizes this information and lets you query it. So what you do, instead of print statements and writing a model to a file, you use these log APIs. When you use them, MLFlow also automatically captures some info about your environment. Like, for example, if you're using Git, the version of the code that you're in our product, it also captures a snapshot of the notebook that you're in if you're using notebooks and things like that. And then once you log these, you can launch a UI or you can run it on a server, and you can see a nice interface for exploring this stuff, where you can query it through an API as well. So what can you do in the interface? You can sort these experiment runs. You can click each one and view stuff. You can log things like models and files in it. You can also write comments about it and sort of share them with people and get some idea of what's going on in there. So just very simple but powerful thing. And actually, this is one of the areas where we've gotten a lot of cool contributions, like even the note-taking feature. We didn't have that in our initial design, and then someone from a financial company in the US opened a pull request and sent that feature. And then the other thing you can do is you can compare these on, so select a bunch of them, compare them, and look at different metrics. And if you don't want to do it in the UI, it's also very easy to do this through the API. There's an API that gives you a pandas data frame, basically, and then you can slice and dice it and see what's happening in there. Or there's a REST API if you want that. So that's the first component. Very simple, but helps with the workflow. Okay, so that lets us see what we were running, but how can we make sure we run it again? So that's where the second component comes in, which is projects. Basically, the questions it's trying to answer are, how can I split my workflow into modular steps? And also, how can I reuse this workflow that someone else wrote? So how can I get the exact same result and same compute environment and so on? And what we do in projects is we have a very simple packaging format for a bunch of code and dependencies. And this can just live in a Git repository. MLFlow understands Git and can talk to it. So basically, you've got your project. You've got whatever code you want in whatever language you want. Actually, we don't really care which one you're using. And then you can have a little spec that says some information about how to run it. So you can provide an environment. We support Conda or Docker for specifying your library environment. And you can also define callable things in the project called entry points. And for each of them, you can also, if you want, optionally, you can define parameters and defaults and so on. If you don't do them, we'll just pass them through on the command line. And so that's all you have to put in. And then as a user, you can, on your machine, you can just do MLFlow run and then the URI of the project to run it. Or you can also call these through an API, and you can also execute them remotely on Kubernetes or on Databricks, the cloud service, or you can plug in your own backend if you want to do something else there. So that's what these look like. Something else that we're working on is easy way to compose projects into a multi-step workflow. So you can already actually use the API to call projects from inside each other, and our user interface knows about it, but we also want to map this into workload schedulers such as Airflow or maybe step functions in the cloud or things like that to let you run this completely autonomously. And then the other thing we're adding is memorization of steps, so you don't have to redo a step if you're calling it with the same parameters. So that's the projects component. And then the third component is MLFlow models for packaging models. So the question here is, how can I reliably pass my model that I built to production applications? And those could be running in a different environment, could be managed by a different team, and I want them to get the same results. So what this does is sort of similar to the project spec. This is a spec for packaging models. And a model is basically, it's a directory with potentially some source code, some data files, like for example, a TensorFlow save models, and also a descriptor that explains how to run it. And one of the cool things we did in our format, so this is different from things like Onyx, which try to save the actual, weights in the network or whatever. This is more oriented around the interface you use for reading it. So it's basically some code that exposes some interfaces. And it's got this concept of flavors, if I can get, well, if you see in the middle there, there's Python flavor, Onyx flavor, you can have others. And what this means is you can have, there's an API that says for any model that supports the Python flavor, I want to load it as a Python function. And then I can run it, and I don't really care what it's doing inside. Or if I've got an inference tool that knows about Onyx and can optimize for it like a specific type of hardware, it can say, hey, does this support the Onyx flavor? If it does, let me get it as a graph. So once you've packaged the model, we have built-in tools that can deploy the same model at many places. So you can deploy it to Docker or Kubernetes or SageMaker or Azure ML for REST serving. You can deploy it to Spark, of course, for batch and stream inference. You can also build tools on top, like debugging tools, testing tools, and so on, that use these APIs from these flavors to do interesting things with your model. And it packages arbitrary code, not just the weights. So that's what it is. So it's a simple concept, but somehow it was kind of missing out there. There were all these binary formats or like no library. There isn't any one that all the libraries support. So we focused on packaging code instead and making it have a little bit more flexibility than just a Docker container, because it's got these multiple flavors. Okay, so that's that. So the other thing that we just launched is a fourth component related to models, which is the Model Registry. And so this is going to be in the next open source release of MLFlow. There's a patch on GitHub for it as well, if you want to check it out. So this builds on the models concept by giving you a centralized hub to manage them. So it turns out, it's very easy to save machine learning models as files, and everyone does that initially. But in large organizations, it becomes really hard to manage when you've just got a bunch of files lying around. So you wonder, where can I find the best version of this model? Am I using the latest, or did that team change it? And there's a different one I should use. How was it trained? All that stuff I mentioned in tracking goes away if you just ship a file to someone. How can I add docs to each model? How can I explain to people, or maybe add some stuff about governance? And also, as we're shipping new versions of a model, can we have basically the equivalent of a code review process, either automated or with humans in the loop to do that? So that's what we are doing in the Model Registry. It's sort of, in a way, it's something like a GitHub for models inside your company, and it also ties in with MLFlow tracking, and of course with all the deployment features I mentioned and APIs. So it's basically a database of version models with info about where they came, comments and tags, and then you've got APIs. So as a model developer, you can push a model into the registry, and then you can have either human reviewers as you pass it through different stages, like you want to mark it to production, or you can have automated tools like Travis CI, and then users can use an API to query. They can say, I want the latest testing version of this model, or I want the latest production version of that model. And this one is supposed to be, so REST serving and batch jobs as well. So what this looks like is you've got, basically a big list of models. Each one can have different versions at different lifecycle stages, like staging and production. And then on each model version, you can add a description. You'll notice that there's some history of who's been doing what to the model. And you can also request, this is kind of like a pull request. You can request that someone change the version that it's in, and other people can approve it. So here I have permission to both request transitions and just transition it. But if I didn't, I would have to, request, and someone else would have to approve this one. So that's what it does. And it also links back, this thing here is a link back to that tracking interface for all the code that went into it. So that's the Model Registry. It's actually been the most requested component among open source users. So we ran a survey of this at the beginning of the year, and everyone wanted this. So we're excited to have this. And again, it's agnostic to where you run this. I'm showing it here in Databricks, if you recognize this part, but you can just run it yourself on a server. And it's also agnostic to where you deploy the models and what library you use and so on. So this is currently in a pull request, and it will be in the next release of MLFlow. So that's kind of a quick tour of it. So we're excited about the uptake that this project had so far, and we're investing a lot in growing it out, actually. So as I said, we've got over 140 contributors from many companies. We talk with a lot of companies who want to run it themselves. We, of course, have customers of our cloud service who want to run it, and really it's basically in all our interest to make it very easy to share ML code and connect it to the best-in-class tools, whether they be commercial or open source. And we've also gotten a lot of interesting contributions from outside. Many of the major features like our API and Kubernetes integration were actually done by other companies who wanted that. And so we're basically, we're trying to set up a great community for people to contribute. Just some examples of use cases. You can actually find a bunch of these at the Spark Summit conferences, so I'm not going to go into a ton of detail. But just as an example, last week we actually had a keynote from QB, energy company in the Netherlands that builds and tracks basically hundreds of thousands of models for things in the electricity grid. So often they're things like individual consumers and their homes, but it could also be things like sources of electricity or batteries or stuff like that. And so they're using MLFlow to manage these, and they're using the APIs, the tracking APIs, to query the results and see what these are doing. Because you can imagine with this many personalized, essentially, models, it's you want a programmatic way to deal with them. Another example is this large online marketplace in the US is using MLFlow projects to package and deploy deep learning pipelines that include Keras and PyTorch. So they develop them locally, and then when it's good, they will deploy remote jobs that that run in parallel on different GPUs and compare the results, and that's what they're using it for. And then the final one, this is an online retailer in the US. It's using it for this problem of how do I ship my model so it runs the same way in production. So it used to be the team was just running, they had a REST server that could just serve queries to the model, but the ML team wanted to own the data pre-processing and post-processing code as well, because they'd have to make a patch into some web application or some other microservice to fix that. There was no way to atomically update both the ML and the business logic. So they actually shifted to MLFlow with a custom Python model that can do both, and they're happier, and their application and microservice teams are happier too, because they don't have to deal with this weird machine learning stuff. So that's just some example use cases. We think this idea of ML platforms is really powerful. We actually also are excited to expand some of this into data engineering too. Some of the things like metrics, tracking, and quality checks make sense in both. And we're excited about this open interface design because you can easily connect it to more features than, and more tools than you could have by yourself. And if you want to try this out, it's really easy to try in Python. It's also got APIs in Java and R, and you can just try it at mlflow.org. So thanks, and I'm happy to take a few questions too.
We have this really cool catch box here, so whoever has a question, who wants to catch first?
Wow, okay. It's dangerous to ask a question, yeah.
This is fun. Okay, so I was wondering about data in this whole workflow. You also need to version data.
Yeah.
I've seen many places are using also other software like DBC in order to version that. I don't know if you have any plan to add that or not.
Yeah, that's a great question. Versioning data, yeah. So you could use this with something like DVC, and you could log the version of data you used. We also, in Databricks, we have this project Delta Lake, which lets you version very large, basically petabyte scale data sets on cloud storage, and it does copy and write a file. So you can easily keep track of many versions as you ingest data and only and not have to copy the whole thing everywhere. So we also have a lot of users using that with Delta Lake for the data that they have in large-scale storage. This is an area actually where we'd like to have more stuff built in, like for example, automatically, remembering which snapshot of the data you were at and so on. But it is quite important.
And another question. Related to Airflow, so in my case, I have a whole pipeline to process features and then get them to the model, and I have this separate. So should be easy to integrate that with Airflow and version in a separate way, this data processing and ML model?
Yeah, it should be pretty straightforward to integrate it with Airflow. So again, because of the way these projects run, you just need to run like this shell command or this Python API somewhere. So your Airflow script can just have a shell command that does MLFlow run. And then you can have your project sitting in there. And you can set, actually, if you want, you can set some environment variable so it points to the right place to log the data and stuff like that. So I've definitely seen people doing that. Yeah.
Okay, thank you.
Okay. You got.
Also related to basically integration with something for data versioning. One use case I have had or have seen is that you operate on streaming data. So your data set is just a stream of data, but your model is stateful. So basically when you're training your model, you need to snapshot your stream at a certain point in time, train the model, and then redeploy it at that exact point in the stream. And this feels like something that need very deep integration with data processing systems, for example, Spark or something else. And is this kind of in the scope for MLFlow?
Yeah, that's a good question. I think for that use case, you would need a system that supports viewing a snapshot and starting over there. So on the streaming side, the structured streaming in Spark supports that. So you can start at a specific point and go forward from then. And in terms of storage management, Delta Lake is the thing that we've been pushing the most, but it may be possible to do it with other ones too. So in Delta Lake, you can say, I want to access this table at this timestamp, and it knows the version that was there. And then you can just remember that and use it in your training jobs and so on. Yeah. But it sounds like it might be very application specific, depending what you need to do. Yeah.
Cool, thank you.
Okay. Yeah.
Yeah, so I was wondering, are you planning to solve the problem of monitoring the drift of the models and that they become worse over time?
That's a great question. Yeah, so we haven't done anything for data drift yet, or actually even for monitoring. We don't have something here. We just, we say, okay, you should do whatever way you normally do. But we are interested in that problem, and we've actually, we've been discussing how to best do that. One thing we've been looking at is to integrate something like TFX data validation. Actually, our director of product for ML led TFX before, so he knows a lot about it. So we're looking at how we can do that in a good way. Yeah.
We have time for one more question before we move on. Any more question? Okay, then thanks once more for Matei.
Thanks a lot, yeah.